the concept first. Okay, so the concept is going to be, this is another famous topics in statistics. Hypothesis. Okay, hypothesis testing or test of hypothesis. That is the topic in question. So what is this? In a statistic, a claim. Testing a claim. In a statistic, a hypothesis. Okay, a hypothesis is a claim. Is a claim, a challenge. Is a claim or a statement or a statement about a property of the population, about the mean, proportion, or standard deviation, about a property, okay, a property of a population. Okay, such as the mean, okay, mean, proportion, okay, mean, proportion, or standard deviation. Standard deviation. Standard deviation and the variance would be the same. So that's the idea. So there's going to be a claim regarding these three numbers because you already estimated for us in the previous chapter. So somebody will come and say, oh, no, it's not. Now, so the claim is going to be called hypothesis. What is hypothesis testing? Is checking the claim. Okay, so a hypothesis. So that was the claim, a hypothesis. Okay, hypothesis test. That's the expression that we have. Or the other expression is test of significance. Test of significance. Test of significance is a standard procedure. Is a standard procedure. Standard procedure for testing. Testing a claim. Testing a claim that we talk about, you see, about that property, about a property of the population, a property of a population. Okay, so the meaning of the expressions that we talk about. For example, you see somebody may claim that, you see, for example, you see, we may challenge these reports, if you like. A reporter, okay, a reporter claims, reporters claims that the majority, okay, the majority of American drivers run red lights. You say that's going to be a claim. You may test it. You may go on and stand, on the road and just check to see how many drivers would run the red lights. Okay, so there's going to be a kind of claims that we are going to check. Okay, now let's see what's going to be the procedure that we're going to have. We are going to talk about one of them in full details to get the idea, the expressions. There are 4 steps that you have to take for each one of them. Then as soon as we are happy with the mean, then we can list the formula. There's a couple of formulas, and at the end, really just the z-test, the t-test that we talk about. It's very similar to the confidence interval. So let's check one of them. We are going to check hypothesis testing. So hypothesis testing. Got to be patient. I have to go through the procedure. Then we get to the example, and you find out it's going to be quite interesting. And you know that this type of operation is going on every day now. All the claims about the coronavirus, this type of the vaccination people, etc., are all carrying out this type of tests. Okay, so what we are going to do, hypothesis testing for the population mean. So there is a situation. We carried out those previous operation that we did have, and we propose a population mean or something. Okay. So when we propose it, it's going to be a number. Okay, that number we usually refer to that mu0. So you are going to be challenging about that value that you propose. So we want to know how we're going to test that challenge. Okay, so we call it hypothesis testing for the population mean. So we are going to testing a value of the mean that somebody will propose. In order to do it, we have to go through this procedure that I'm going to write it down for you. Okay, any question? Everybody understand what we're going to do? So somebody claimed that the population mean of the mean salary of the company is going to be $2,000. You say, oh, I don't believe it. So we don't believe it, so I'm going to test it for you. I'm going to provide some information. Now, your test would follow this procedure. The first expression that we are going to use is null hypothesis. Null hypothesis. What is going to be null hypothesis? You see, null hypothesis is a claim that you are going to test it. We call it null hypothesis. Somebody said that the population mean is equal to the 80, so that would be your null hypothesis. So a claim or a hypothesis to be tested. Hypothesis to be tested. To be tested is called the null hypothesis. Null hypothesis. And is denoted by H0. H naught we call it. So in all these problems, you have to give us your H naught. That's it. This is going to be null hypothesis. Any question? That's the first one. What's the second one? Okay, null hypothesis is the number that you claim. Say mu equal to the 50. Say, oh, he's not. He's not. So what's the alternative? What is your suggestion? Do you suggest it's less than 50, greater than 50? So there is going to be alternative one. Alternative hypothesis. So the H naught is already there. So alternative hypothesis will be alternative of whatever you put over here. So it is hypothesis. It is a hypothesis, a challenge. It is a hypothesis to be considered. As an alternative. An alternative to the null hypothesis. Null Okay, null hypothesis. Now it's denoted by, it is denoted by H1. So in all the problem, you have to give us what is your H0, what is your H1. Okay. Now let's see what's going to be, how many cases are going to have, what's going to be the way you are going to write the H1. Okay. So null hypothesis is the value that you're going to be given. Okay. So that's going to be claim or challenged. And then you have to write your alternative. Okay. So what we are going to do is, as I talk about it, we are going to checking the value for the mean. So we are going to have these type of procedures. And there are different ways to set up the problem. But the way I set it up is a little bit different from your book, but it's much, much easier than the other cases. Okay. So we considered, that's important, but we considered the null hypothesis, the null hypothesis, null hypothesis for a hypothesis test. Okay, hypothesis test. Okay, concerning a population mean, a population mean mu, always, is it considered always to be, always specifies a single value for the mean, if you like, for the mean. What does it mean? This means they are going to give you a number that's going to be claimed for that population mean. 50, 60, whatever it is, we are going to consider, we are going to call that one mu0. And then we set our null hypothesis be the fact that this mu is equal to the mu0. In some book, they go with the less than, they look at the problem and they set up this one. But the way I do it, or the way we are going to do it, is going to be a fixed one. So the fixed one would be, this means we are going to express, so that's important. We always express, because a value would be given to you. So take that value. We always express the null hypothesis, okay, for the population mean, as following. You see, H0 is the fact that mu is equal to the mu0, that number that's going to be given to you. Okay, where mu0 is a given number. Because there is a value that you are going to be challenged, the claim. Always let your null hypothesis be this one. Don't change it. Do it for all the problems. You see the advantage. Okay, any question? So whatever is given, we call it H0. Now, what is the alternative? For the case of the alternative, okay, you see, suppose, just think about it. Suppose null hypothesis is the fact that the mu is equal to 50. What is the alternative of mu equal to the 50? Any suggestion? Any suggestion? You claim that the population mean, okay, the population mean is 50. Somebody else will say it's not. So what does it mean? It's not in mathematics, mathematically, if you want to write down symbolically. Any suggestion? Mu equal to the 50. If somebody say it's not, so what does it mean? Any suggestion? If mu is not equal to the 50, so what's going to be the cases for the mu? Mu can be less than 50, or mu can be greater than 50. Okay, so there are, if see, the alternative is going to be 3 cases, and the problem will guide you. In this case, there are 3 choices, and that gives you 3 different problems. 3 choices for the alternative, alternative, okay, hypothesis. Which one are you going to use? You read the problem. The problem will guide you. Case 1. You see, case 1. The case 1, when you read the problem, they say, oh, I think the population mean is less than 50. So that's going to be your first case. You have to look for this expression. The population mean is less than that number, less than mu 0. You see, you will see this one in the problem. If you see this one, you set up your alternative, say, oh, okay. So this is going to be the one that I'm going to check. H1 alternative is mu less than mu 0. See, that's the case that you set up. So you read the problem. According to the problem, you are going to write the alternative hypothesis, H1. And since it's less, there is an expression that we're going to use for the table, and we are going to call this one, you see, and the test is called, because you change it to the probability, eventually that's going to be area to the left of the Z, if you like. And the test is going to be called a left-tailed test. Use this expression when you want to find the, okay, we want to use the table. Less, you go to the left-tailed test. Any question? That's case 1. That's a case 2. They may say, oh, the population mean is greater than mu 0. If they claim this one, quickly you say, oh, so I have to check this one. So you are going to write your H1 as what? H1 is the fact that the mu is greater than mu 0. And eventually it's going to be Z curve, the area to the right for the probability. So, and the test is going to be right-tail test. And the test, okay, the test is called a right-tailed test. Right, because it's greater than. Question? So, less than, greater than. What next? We have another one. They may say simply, the population mean is not mu 0. So the population mean, okay, is different, is not, is different. Is different from mu 0, not equal to, different. If this is going to be different, we write, how we write it down? We write H1 as mu not equal to the mu 0, you see? And the test is going to be called two-tailed test, to the right and to the left. And the test, okay, the test is called a two-tailed test. Two-tailed test. Okay, so you have the right, you have the left, and you have a two-tailed test to get your alternative. So this means you are going to have, okay, you are going to have three cases and the three problems that we have to take care of it. Okay, any question? That's a step 2 of our problem. So there was a case that we want to check. So you set up one of these. Okay, you set up one of these, depends on the problem that you're going to have. Then the next thing is you need a machine. You need a probability machine. Remember, we did this type of ideas before. When it was, for example, mu less than mu naught. Remember, somehow we related to the z-score when we get the confidence interval. It's going to be the same thing over here. So it depends on the nature of the problem. You need a test. So that's going to be our next step. The next step is what test? How are we going to check it? So this part is going to be called test statistic. A tool. Test statistic. You have to change this into the Z or the T to be able to do it. What is going to be the machine that we're going to use? Okay. So the test statistic is going to be, this is it, the test statistic is just a machine, is a tool, is a value. It's going to be a value that we can find it from the information from the, okay, from the sample. It's computed from the sample. You see, in order to challenge it, to test it, you go and you provide the sample data. Okay, and we are going to use it to make a decision. And it is going to be used in making a decision. Are you rejecting the claim? Are you accepting the claim? Making the decision. Sorry. Making a decision about that null hypothesis, about the null hypothesis. Okay, null hypothesis. Now, there are two cases, of course, sigma known, sigma unknown, as we did it before. So there are two cases again, two cases for test statistic, test stat. Case one we call it z-test. The case 2, we call it the t-test, as we did it for the confidence interval. If sigma is known, you see if sigma is given to you, is known, use this one. Z, we call it Z naught. Z naught equal to X bar minus mu naught divided by the sigma over radical n. The formula for the z-test. Okay, if not, if sigma is not given to you, if sigma is unknown, use t-test. T0 equal to the, again, X bar minus mu naught. You know that it's going to be S over radical. So that would be the second step of your job. This is the only mathematics that you do in this problem for us. Okay, so we set up the null hypothesis, we get the alternative one, we have a machine. This machine, there is going to be no information from the sample, because in order to check it, you have to provide some evidence. You go around and you pick a sample and you find the mean. So from that sample, you get this information. Then you have to get the probability. What is the probability that you will get your result? Now, for the next case is going to be next step. There are different ways to do it. There is one way that we're just using graph, okay, critical values one. And there is going to be another way, easy one, to find the probability very similar to the one that we did before. We call it p-value. So the next step is going to be, I go with this method only, p-value method we call it. It's a kind of a modern version and it's very easy to apply. What is the p-value? P-value or probability value. P stands for the probability. Probability value. So what's the p-value? You see the p-value is the probability area under the curve, you know that. You have the z-naught here, you see you have the z-naught here. You have the z-naught, and depends on which of these cases are going to be. You see these cases. The first case was a left tail test. So this means you read the area to the left of the z. The next case is going to be right tail test. You read the area to the right. And the last one is a two tail test. So means, you find the area to the right or to the left and you multiply by 2. That gives you the probability in question. So we are going to tell you how we're going to find it. This is it. So the p-value again is the one that we're going to use to get this information. So the p-values or the probability. P-values can be found. This is like the one that we did before. Depends on the test by using. Okay, I do the C test only, then the T test I explain later. P-values can be found by using the following procedure. The following procedure. It's like the one that we did before, the area to the right to the left. So for the left tail test, left tailed test. For the left tail test means this is where the mu is less than mu0. So your p-value simply would be the p-value. The p-value is simply probability that z is less than z-naught. Area to the left of the z-naught. That's it. We did it before. You see that's going to be the z-naught. So this area is going to be your p-value. Any question? It's the same thing that we did before. We go to the table and we read it. The second one, the right tail test. If you have the second case, right tailed test. Right tail test is when the mu is greater than mu0. So the p-value would be area to the right. Okay, so the p-value or probability is going to be p of z greater than z0. You know that this is it. So if this is going to be z0, you are interested in this area. You know that you are going to find it and you subtract it. Remember, it's area to the right. So you get the area to the left and then you just get the complement. Okay, question. So left tail, right test, area to the right. Two-sided one, you got to be careful. for the true tail. So the third case is going to be, what is the true tail test? True tail test. This is where mu is not equal to the mu naught. You see, algebraically, this is what would happen for you. So your p-value, you want to find the probability that z is not equal to the z naught. You see, you have two choices. You see, this is a situation you're going to have. I say this is a situation you're going to have. So this is going to be your z naught, positive z naught, and this is going to be your negative z naught. So your situation is you have to find this area and this area, not because z can be greater than z naught or can be less than z naught. So this is going to be half of the p-value, and this is going to be half of the p-value. So what you can do is you can find the area to the right of the z naught multiplied by 2, or you can find the area to the left of the negative z naught multiplied by 2. Okay, so this is going to be equal to the twice of the p of the z greater than z naught, or one of these. P-value is going to be twice of the p of the z, z less than negative z naught. I prefer this one, because if you go with the first one, is the area to the right. If you want to read the table, remember, the table give you area to the left only, then you have to find the complement. So always get this part. Okay, the area to the left is going to be one reading, and even if you want to use calculator, it's going to be much easier. And I'll show you. Okay, so that's going to be the true tail test. Any question? So we did all these. So what's the result? What's going to be the conclusion? So in order to get the result, you see, you get the number here, the probability. You know, probability is going to be any number between 0% and 100%. So how are you going to decide? Okay, so in order to decide, you have to set a limit for us. Remember the limit that I did before? I told you that anything less than 5% is like 0. That 5% was my tolerance, if you like. In this type of problems, you have to tell us what is your tolerance is. In some sensitive materials, you may go with the 1%, 2%, 3%. So you have to give us that number. That number is going to be called significance level. This would be given. What is significance? Okay, what's going to be significance level? Remember, for the confidence interval, we did have confidence level. I denoted by C. In this case, it's going to be significant level for this type of problem. We denote it by alpha. So you can't miss it. If you see significant level, you find out that the problem is test hypothesis. If you see confidence level, you find out that's going to be, that's a confidence interval problem. So what is going to be this one? This is going to be a number that enables you to reject or support the claims. So it is the probability. The probability of rejecting. Okay, rejecting the null hypothesis. The null hypothesis when it's true. I'm going to explain what does it mean. It's denoted by, it is denoted by alpha. Denoted by alpha, and it's used, and it is used to make the final decision. To make, okay, a decision regarding that challenge, regarding rejecting or supporting, rejecting or supporting the claim. Okay, now how are we going to do it? This is the conclusion. When you do all this operation, you find your probability. Then you consider these 2-3 cases. Okay, the cases are going to be if the p-value that you got, it's even less than that significant level, less than 2%, 5%. Then if this is going to be the case, you reject the H0. You reject the null hypothesis. When you reject the null hypothesis, means you are in favor of the H1, if you like. Then you have to support the H1, the alternative. Otherwise, if P is going to be greater than alpha, then you support. Okay, you support the H0. So support the H0 means, okay, you know, sometimes we say support the H0, or we say do not reject. Do not reject the H0. We don't usually use the word accept, okay, because this is just based on your information. So we usually say refute and we say support, okay, or reject or do not reject the H0. And then you have to make a, nice sentence for us. That's a procedure. I give a break. We come back and we do it. You have to do all these 5 steps that I talk about it. It's going to be easy procedure. And at the end, make a next comment. Some people, they do everything. And they do this one, but that last sentence doesn't make sense. So as you can see, it's going to be easy procedure. Let's have a break, short break. It's 12:43, 10 minutes. We come back and we give an example. And this is, of course, for the z-test. And there is going to be something similar to the t. Everything is going to be the same except that test statistic. So let's get practice on this one first to get to know it, and then we go with the other ones. Okay, so 10 minutes, we come back and we give examples. We need 3 examples, and we give you 2 out of these 3 on this quiz and on the final. Okay, see you in 10 minutes. Okay, so let's give you some examples to see how we're going to operate with this method. So what I'm going to do, I'm going to give you some short or example with the summary of the information first, so you know that how we're going to pick this information from the given problem, and then we just to give you, the couple of actual one. So that's it. Example. See there, suppose there is a claim that we are going to test it. So somebody claimed that the mu, the population mean, is less than 5.3. Okay, so this claim should support with some information from the sample that you have to check these numbers. You have to pick these values from the problem. So we call it sample data. Sample data should include the sample size. The sample size in this problem is going to be 32. Should give you the sample mean. All of them would be given to you. So that's going to be 4.2. And they should give you sigma, which is going to be population standard deviation of the 1.9. And there must be a level, give you significant level. Significant level would be alpha. Alpha equal to the 1%. It's going to be very a small number, mostly less than 10%. Okay, so you want to test the claim that the mu is less than, somebody say mu is less than 5.3. You say, oh, I'm going to check it for you. What I do, I go around and I pick a sample with this information. Now, how are you going to set up the problem now? Solution. You see, step one of your problem is going to be null hypothesis and the alternative. Step one, null hypothesis, we talk about this, always would be of the form of H naught is mu equal to this given number, mu 0, 5.3. Always use equality. That's H naught. H1, alternative. Alternative one is this claim that the mu is less than 5. So alternative is going to be mu is less than 5.3. You check, since it's less, it's a left tail test. So you have a left tailed test. That is a step one. Any question? It's the way you do it, on the test or the problems. So H naught is always equality. Mu is equal to the 5.3, the values that's given to you for the mean. H1 is the alternative, the claim. So it's a left tail test. That's a step one. A step two, the machine. Test a statistic. So what's going to be test a statistic? Okay, test statistic. So you check sigma is given to you. So you use the z-test. If the sigma is not going to be given, we use the t-test. We talk about that one later. So we say, oh, sigma equal to the 1.9 is given. And so the z-test should be applied. Should be applied means z or z naught is going to be equal to the x bar minus mu naught divided by the sigma over radical n. You substitute. X bar is 4.2. Mu naught is 5.3. Divided by sigma of 1.9. Radical n, the sample size of 32. That's it. Use your calculator to get these numbers. If you subtract the top, it's going to be a negative number, 1.1. And this is what I did. So that gives you negative 3.23. Remember, that's a z numbers. You have to round it up to the 2 decimal places. So the z naught is going to be what? negative 3.23. That is going to be the Z naught. Any question? That's a step 2. A step 3, probability. P-value. P-value. See, what type of test do you have? Left tail test. Area to the left of the Z naught. So you remind yourself that it is a left tail test. Left tailed test. So your P is going to be probability that Z is less than Z naught, which is going to be probability that the Z is less than negative 3.23. You go to the table and you find it, you see that's going to be the one. It is a negative 3.23, the area to the left. If you go to the Z table and you find this number, it's very a small number. It's going to be it's going to be 0.0006. Okay, 0.006, and this is it. So the P of here, so the P would be 0.0006, which is very a small number. Okay, that's a step 3. Any question? Step 4 is the conclusion. So what's going to be conclusion? You compare this one with the alpha. P is 0.006. Alpha is what? 1%, which is 0.01. If you compare them together, 0.006 is less than alpha. So P is less than alpha. When P is less than alpha, you reject the H naught. Reject the H naught. Okay, any question? No, you are not done. You have to make a comment about the claim. The claim is mu is less than 5.3. So what are you going to tell us? When you reject the H naught, you see, this means you are not going to believe in this one. When you reject the H naught, means you believe in the second part. So this means there is sufficient evidence to believe that the mu is less than 5.3, and we support the claim. Okay, this last part, make sure that your sentence makes sense with the given information. Reject the H naught means you are in favor of the H1. So you have to write a favorable sentences for the H1. So you're not done. You have to give us this information that there is this expression that we use. There is sufficient. There is sufficient, okay, sufficient evidence. Sufficient evidence to support, okay, or support, sufficient evidence that mu is less than, that mu is less than 5.3, and you support the claim. Support the claim. This last one, some people, different people write different things, but just give us something that this is going to be the case. Any question? So it's not a difficult procedure, but make sure that the things consistent, make sense. This probability is almost 0. Okay, 0.0006 that you have. So it's less than whatever you have for the, your significant level. So you reject the H naught in this case. Reject the H naught means you are in favor of the H1. So write something nice for the H1. So there is a sufficient evidence. This is the evidence. Sufficient evidence that the H1 is true. So sufficient evidence that the mu is less than 5.3. And that's exactly the claim. So you support the claim. Any question? You see, that's it. That's that one. And this is all you are going to do for us. Let's give another one. Then we give you the actual one. Next. It's going to be the same for the rest of the course for all the other problems, the same thing. So what's this one? You see, there is a claim that we want to check, and you will see the actual problem later. Somebody claimed that the mu is going to be something like a salary. So the 24,000, okay, 819. That's a claim. So we need support evidence, sample data. Okay, so what is going to be the sample data? They go around and check this one. They get a sample of 40 people. Okay, they find the mean. Okay, the mean is 25,910, and the standard deviation of 1,917. And we want to test these claims again, alpha equal to the 1%. Okay, that's it. Are you ready? Solution. Step one, set up the problem. Step one, the H naught, as usual, is going to be the fact that the mu is equal to the given number, 24,819. Alternative one is the claim that the mu is greater than 24,819. Okay, it's greater than, so it's a right tail test. Okay, a right. This would be helpful when we want to find the probability, right tail test. That's a step one. Question. Step two, machine. Test stat. Again, sigma is given to you, so it's going to be the z-test. Okay, sigma equal to the 1,917 is given. And so we're going to use the z-naught, which is equal to x bar minus mu naught sigma over radical n. Substitute. So the 25,910 minus mu naught, 24,819 sigma 1,917 square root of n is 40. Okay, simplify these numbers. So that's what I got. You can check it with your calculator. Test that. 1,091, and this is going to be 303. So I got 3.6. Remember, 2 decimal places only. So the z-naught is going to be 3.6. So that would be your z-naught. Any question? That's a test, a statistic, probability, p-value. It's a right tail test. So you have to find the area to the right of the z-naught equal to 3.6. Okay, so it is a right tailed test. So the p is equal to the p of z of greater than 3.6. So you have to be careful. So you have to find the complement. You see, it is going to be 3.6. It's area to the right. So what you have to do is you find the area to the left. You see the p is equal to p of Okay, it's going to be P of Z, I'll just repeat it. So it's going to be 1 minus. If you go to the number 3.6, you don't have it on the table, but you just pick the last number. That gives you 0.9998 on the Z table. For this number that we are going to have. See, this is going to be the Z 3.6. You see the last number 3.4 that you have is this one. It's almost 100%, but we don't usually use the one. Okay, so this is 3.4. So for the 3.6, you just pick the last number here, 9998. Okay, so you find the difference. The difference is going to be very small, 0.0002. So the p-value is going to be equal to the 0.00002. Okay, any question? Conclusion? The conclusion is going to be your p number is 0.002, which is very small again. Alpha of 1%. So 1% is 0.1. So p is less than alpha. You reject the H naught. Okay, rejecting the H naught means you are in favor of the H1. Okay, and the H1 is your claim. So again, you have to give us, it's a coincidence to get rejected for both of them, but it's nice, no worry. So you have to make a comment, there is sufficient evidence. Okay, we make a sentence regarding to H1 all the time. There is sufficient evidence to conclude that the mu is H1, you see, is greater than 24,819. Okay, that's going about 8. When you reject the H naught, means you are in favor of the H1. So the H1 was the claim that the mu is greater than 24,819. So you support the claim. Okay, support the claim. Okay, to get these numbers. Okay, so that only that p-values, the part that's going to be different is going to be your your p-value part. Otherwise, the rest are going to be the same thing. Okay, so let's give you another one. Any question? So what we need one more to get the, let's have one more, the two-tailed test. So the right, the left, you see that probability part really is like the one that we did before, but make sure you set up the problem nicely. Any question? So right, left, you need one for two-tailed test. Okay, so example. Let's see one we can get for the two-tailed test over here. Okay, so this is going to be a two-tailed test. I just give you the actual problem so that you know how I'm going to pick this information out. Okay, so this is it, a data set. Okay, a data set list. Okay, list a sample. So you know how I'm going to pick out those information. A sample of 106 body temperature. Okay, body temperature. Body temperatures. Okay, we began the 60 adult person, if you like, and we check the body temperature. So data set at least a sample of 106 body temperatures having a mean of, you know, that the actual number, mean of 98.220 degree Fahrenheit. Okay, that's it. So we pick a sample of 106 people, and the mean temperature of their body is 98.2. So what's the question? The question is going to be, suppose the population standard deviation. Population standard deviation. Standard deviation is known to be what? 0.62 degree Fahrenheit. Okay. So the sigma is also given. So what's the question? The question is use a 5% significance. Okay. So as soon as you see this expression, you know that this is going to be hypothesis testing. Use the 5% significance level. 5% is your alpha. Okay, to test the common belief. Okay, common belief that the mean, okay, the mean body temperature, okay, mean body temperature of, okay, of healthy adults is equal to that's a tricky one. Let me just show you what's the point about this one. Okay, so you read the problem carefully, you go right at the end to see what are you going to do. So at the end, they want you to use a test hypothesis to check, you see, believe that the mean body temperature of healthy people is equal to the 98.6. So when you want to set up this problem, there is a claim that we're going to check. The claim is, you see, the claim is that the mu is equal to 98.6 degree Fahrenheit. Because you want to test that, you know, the common belief that's the case that the mu is this one. So in order to test that, you need the sample information, okay? So what's going to be the sample data? Sample data start with the sample size, 106 people. Sample mean. The sample mean was 98.20 degrees, okay, Fahrenheit. Sample standard deviation is given to you is a 0.62 Fahrenheit degrees, okay, and the alpha is given 5%, alpha of 5%. If that's exactly this information would be given to you in sequence when you put them together. Okay, so the problem would be given, so you just pick up this information. Okay, this is equal to, that's going to be a tricky one. Okay, are you ready? The first part, the null hypothesis. The null hypothesis, as usual, is mu equal to the 98.6, okay, degrees. Now what's going to be the alternative now? You see, your alternative now is going to be that the mu is not. You see, it's not. Because the equality side is given to you in the problem. And since we set up with the equality all the time, okay, it doesn't matter. So again, the H naught is going to be mu equal to the 98.6. So the alternative for this type of problem is going to be that. Okay, so that's a two-tailed test. Any question? Two-tailed test. Okay. Test stat. Test statistic. Again, sigma is given to you. Sigma 0.62 degrees is given. And so we have to use the z-test. Z naught is going to be equal to the x bar minus mu naught. And that's a sigma over radical n. If you substitute, so the x bar is 98.20, mu naught is 98.6, sigma is 0.62, square root of n is 106. Okay, if you use your calculator, the number is going to be a very big one. Okay, the number is negative 6.64. Okay, so your Z naught is going to be negative 6.64. That's going to be your Z naught. Okay, so it's going to be test stat. Now we need the p-value. P-value. So what's going to be the p-value? P-value. You know that it's a two-tailed test. Okay, it is a two-tailed test. Two-tailed test. I'll talk about how we're going to pick this one. Let's look at this one. The number that you have is going to be negative 6.64. And this is going to be positive 6.64. So I talk about it. You can pick this area you multiply by 2, or this area multiplied by 2. This is always easier, the area to the left. Because for the area to the left, you just have one number. If you pick the area to the right, you have to find the complement, then multiply by 2, and probably you made a mistake here. So always go for the area to the left and you multiply by 2 because it's a two-tailed test. Okay, so what is going to be the P number? So the P is going to be twice of the P of the Z less than negative 6.64. You don't have this number into the table because the last negative number that you have, okay, look at this one. The last negative number that you can have is a negative 3.4. So you don't have the 6, we usually take the last, this is the one, 0.0002, because it's almost 0. Okay, so you pick this one. So this number is going to be, you see this area is going to be 0.0002. So your p-value is going to be 2 times 0.0002, which is going to be 0.0004. It's very small. Your alpha was 5%. So if you compare them together, again, you have the case that the P is less than alpha. It's coincidence, all of them was P less than alpha. Okay, so you have to make a nice comment. I'm going to put it over here so that we can have it and explain it. So what we have is the P is equal to the 0.0004 and alpha of 5%. It's a big number. It's a 0.05. So P is less than alpha. Less than alpha, reject the H naught. Okay, let's see what does it mean. Reject the H naught means you are in favor of the H1. So what's the H1? H1 is the fact that the mu is not equal to 98.6. Okay, so there is sufficient evidence. Sufficient evidence that mu is not equal to the 98.6. Now, how about the claim? The claim was that the mu is equal to, you see, is equal to. So this means you reject the claim. Do not support the claim, or reject the claim. Okay, mu is not equal to the 98.6, so do not support or reject the claim, or refute the claim. This is the way we write it down. Okay, refute the claim. Or reject the claim, do not support the claim, something like this. But some people will be confused with this case that we have. Because the equality sign is given to you, so the alternative would be mu not equal to. So you reject the equality sign. So means there is a sufficient evidence to believe that mu is not equal to 98.6, but the claim was that is equal to. So that's why you refute the claim or do not support the claim. Okay, so that gives you three cases, and we give you more next time. Any question? So as you can see, it's not a difficult problem procedure, but you make sure to give us everything in this form on the test. So it's a 3 cases. We give it 2 out of 3. Then we can do it with the t-test. You need that for the table. It's going to be much easier. Make sure you bring. Remember that table for the t that I gave you. We didn't use these 2 parts. You see, these 2 parts can be used for the p-values. You can use your TI-84 to get the p-value for this one. I'll show you next time. But this one is much easier because we are not interested in the value of the p-value. We just want to compare it. You see that the last part that you did, you just want to compare the alpha and the p. So if you just know what is it p bigger than 5% or less than 5% would be enough. That's why from this table quickly you can find out. I'm sure you both of them. Just pick the one that you like. Okay, there's going to be a similar one for the t. Only this is a z-test. The other one will be t. So just give a couple of examples on that one, and then we are done with all these test hypotheses that we're going to have. Test